Hello everyone, my name is Archana Neopaney. I am from Namchi Government College, second semester Physics Honours, and today my topic is to explain Norton's Theorem. First of all, I would like to thank Physics Department of Namchi Government College and also Dr. C.P. KHATIWATA sir for giving me this opportunity to explain this topic. So friends, let's take a linear complex network which has a voltage source and also sources of resistances. Okay, the EMF of voltage source is E, which is constant, and we have R1, R2 and R3 as resistances. Now we need to find the value of IL flowing through RL. We can find the value of IL by using Kirchhoff's voltage law. But it will be very difficult for us to find the value of IL using Kirchhoff's voltage law because of hard equations. So, Norton's gave us one easy formula to find the value of IL. So, according to Norton's equivalent circuit, we will have only one current source and a voltage source. And the condition is that a current source and a voltage source must be parallel to each other. So easily we can find the value of IL using Norton's theorem. So we have one formula to find the value of IL. That is, IL will be equals to IN cross RN whole divided by RN plus RL. So friends, let's see this statement of Norton's theorem. It states that a linear network consisting of a number of voltage source or resistances can be replaced by an equivalent network having a single current source IN and a single resistance RN. So, Norton's theorem says us that a linear network which can have a number of voltage source and also a number of resistances. Here we just have one voltage source, that is, it has an EMF E, but we can have many voltage sources. So here we have a linear network source. The resistances here are R1, R2 and R3. And we just have one voltage source and the EMF of a voltage source is E. We can also have many voltage sources. It's okay to have many voltage sources, but we just have one over here. And according to Norton's theorem, we can convert this linear network into an equivalent network where we will only have one current source, single current source and also single resistance, that is IN and RN. And the condition for Norton's theorem is that this IN and RN must be parallel to each other. So we can easily find the value of IL using Norton's theorem. We have a formula. IL must be equals to IN cross RN whole divided by RN plus RL. First of all, we need to find IN and RN to use this formula. So friends, let's find the value of IN and RN steps by step. Step 1. Find load on the source, short the load terminals A and B. So first of all, we need to find load over here. To find the load, we need to sort A and B. That is, we need to remove RL. Okay. Let us assume that the load on the source be R dash. Okay. R dash will be equals to R1 plus R2 parallel R3. Here, R2 is in parallel combination with R3. And R2 parallel R3 is in series combination with R1. So, equivalent resistance of R2 parallel R3 will be R2 R3 whole divided by R2 plus R3. So, R dash equals to R1 plus R2 R3 whole divided by R2 plus R3. By taking LCM, we get R1 R2 plus R3 plus R2 R3 whole divided by R2 plus R3. So by multiplying, we get the value of R dash as R1 R2 plus R1 R3 plus R2 R3 whole divided by R2 plus R3. This is the load on the source. Step 2. Find source current. Let's assume source current as I dash. Okay. The formula for finding source current is E divided by R dash. That is voltage divided by resistance on the source. So friends, we have already got the value of resistance on the source from step 1. That is, we got R1 R2 plus R1 R3 plus R2 R3 whole divided by R2 plus R3. So now we can put the value of R dash in this equation. So after putting the value of R dash in this equation, we get the equation as I dash will be equals to E whole divided by R1 R2 plus R1 R3 plus R2 R3 divided by R2 plus R3. So friends, we can take this value in numerator. When we take this value in numerator, our equation will be I dash equals to E inside the bracket R2 plus R3 divided by R1 R2 plus R1 R3 plus R2 R3. Step 3. Find Norton's current. That is IN. To find the value of IN, we can use current divider rule. That is, IN will be equals to I dash R2 whole divided by R2 plus R3. So friends, we have already got the value of I dash from step 2. That is, I dash equals to E inside the bracket R2 plus R3 whole divided by R1 R2 plus R1 R3 plus R2 R3. So we can put the value of I dash in this equation. After putting the value of I dash in this equation, our equation becomes IN equals to E inside the bracket R2 plus R3 R2 whole divided by R1 R2 plus R1 R3 plus R2 R3 R2 plus R3. So after cancelling numerator with denominator, we get the value of IN as E R2 whole divided by R1 R2 plus R1 R3 plus R2 R3. So this is the value of Norton's current. So after this, we again have one more step where we will learn to find the value of Rn. Step 4. Find Norton's resistance. That is Rn. So to find Norton's resistance, first of all, we need to open the load terminals AB, which we had sorted before. Also, we need to disconnect the cell. Here, R1 and R2 are in parallel combinations. So, we can call Rn, that is load resistance, as open circuit resistance also. So, we can find the value of Rn by using the formula Rn equals to R3 plus R1 parallel to R2. So, Rn will be equals to R3 plus R1 parallel to R2. So, the equivalent resistance of R1 parallel to R2 will be R1 R2 whole divided by R1 plus R2. Therefore, the Rn, that is Norton's resistance, will be equals to R3 plus R1 R2 whole divided by R1 plus R2. So, we have already got Norton's current from step 3. So, we can easily find the value of IL by putting the value of Rn and Rin in the equation. So, let's try to draw Norton's equivalent circuit. So, we have already got the value of Rn from the equation, and also we have got the value of In from step 3. So, by putting the value of IN and RN in the equation IL, that is IL equals to IN cross RN whole divided by RN plus RL, we will easily get the value of IL. So here we have one problem. That is, find the given circuit. Determine the current flowing through 10 ohm resistor using Norton's theorem. So, to find the current flowing through 10 ohm resistor, first of all, we need to remove the load resistance and sort A and B. To find the value of IN, first of all we need to find the total current in this circuit. As we observe this circuit, here 3 ohm and 2 ohm are in parallel combination with each other. And the parallel combination is in series combination with 1 ohm. That is, R dash will be equals to 1 plus 2 into 3 whole divided by 3 plus 2. That is so the total current IT is given by V divided by R dash. That is, here we have 9 divided by 2.2. When we solve it, we get 4.09 ampere. So the current flowing through 2 ohm resistor is given by applying current division rule. That is, IN equals to IT cross 3 divided by 3 plus 2, which will be equals to, we have got 4.09 into 3 divided by 5. After solving this, we get the value at 2.454. Our second step is to find Norton's resistance. To find Norton's resistance, we need to remove the load resistor and short the voltage source. That is, as we observe the circuit, we can see that 1 ohm is in parallel combination with 3 ohm and the parallel combination is in series combination with 2 ohm. Therefore, the value of Rn will be 2 plus 3 into 1 whole divided by 3 plus 1, which is equals to 2 plus 3 by 4. After calculating, we'll get 2.75 ohm. Next step is to find Norton equivalent circuit. So, this is so we have already got the value of IN and RN from our previous equations. That is, IN equals to 2.5454 ampere and RN equals to 2.75 ohm. And we have got the value of RL from the question. That is, RL equals to 10 ohm. That is, now finding the value of IL, we get IL equals to 2.454 into 2.75 whole divided by 2.75 plus RL, that is 10, which will be equals to 0.529 ampere.